Okay, hello. This will be a demonstration of the project Smart Greenhouse for the course Programming for IoT at Politecnico di Torino. Okay, so let's start. Here I've pre-run all the required code for this project. The catalog mainly here, it's just sends, it's just like an API that helps us reach the value of the setup file here. The setup file here contains all of the required values, for example, the ID, the token for the Telegram bot, the user list that are registered to this Telegram bot, freeboard, the IP of the dashboard, the IP of the web API, the broker also. It also has information about each zone we have here. The control here mainly it has control strategies that read values of the sensors which are sent by the broker, and it in turn it gives some kind of control signal which actuates pumps, fans. Here are represented by LEDs and indicators. The freeboard is just our dashboard. It contains all the value. In the dashboard here we have some file called format. This format becomes useful when we want to set up new zones. As soon as we send the setup message to our system, it automatically generates another JSON file. We'll test that in the end, and helps us run the freeboard without having to predefine anything. The MQTT web is just simple, as name says. It reads the values from the MQTT through this get data, saves them into this data.json file, and then the web API publishes them to the internet mainly. Whereas on the Raspberry, it contains the file on the Raspberry. I have the Raspberry connected here. You can see all the files are on my desktop here. And the Telegram bot is just a simple Telegram bot that handles messages and helps us send emergency notifications. Okay, let's go into the project a little bit. Okay, so I have the project run. Okay, so this is the main page of our greenhouse management system, the smart greenhouse. You can see here a list of all available zones. If we go to settings, this is the settings of one zone. Okay, so let's go to our catalog. As you can see here, if we go to zones, you can see a list of all zones. Note that the catalog works on URI, so every link is reachable by a URI. So if we go to zone 2, we can also reach zone 2. Okay, so let's say you want to update the plant name. Let's use tomatoes, and I want to update the humidity margin for 2. Okay, the previous value here was potatoes and this was 3. So as I update, I return to the home page, but if you can see here, when I refresh, the values are updated and we're good to go. And here also the name is updated. It was potatoes, now it's tomatoes. It automatically changes as you change or add zones. For example, let's go into tomatoes. Okay, here you can see our freeboard. Mainly it has this gauge for water level. It has these graphs that plot the sensor values, and these are just indicators for different actuators of our system. And here it shows the plant name. Currently I haven't run my sensors, but we'll get to that soon. Okay, if you can see here, we have the setup. Mainly we have just the Raspberry Pi connected to 3 sensors: the DHT, the ultrasonic sensor, DHT to measure the temperature and humidity. This ultrasonic sensor is to simulate some kind of like water level, and this is the soil moisture sensor, and we have here an ESP connected to a couple of LEDs for actuation. Okay, so let's go and test, for example, the moisture sensor here, so let's see how its effect on the system. Okay, so now I'll just run the moisture sensor here, soil moisture. Okay, as you can see now I'm publishing the values. and here you can see the sensor. Let's remove the sensor from the water. As you can see now, the moisture is low. I've received a notification on Telegram, and the sprinkler turned on. If I return this back into the water, the sprinkler is now turned off, and I receive also a notification stating that sprinklers are off. The same concept is valid for all sensors with different functionality mainly. Okay, so let's take for example the water level sensor here. Okay, so I'm gonna run. I'm just gonna run. Okay, so now we're below the water level that we defined before, which was 40. Okay, so now the sensor is 0, mainly it's reading 0, and as we increase the water, like now it's greater than the limit, but the pump is still on. This pump functions in the sense that it has to reach almost 90%, and then it would turn off. For example, now I've reached 100% and it's currently off. Okay, so let's turn off this sensor here now. Okay, and as you can see, I'm always receiving notifications. Okay, let's go to the Telegram bot a little bit. Okay, so I'm gonna go back here to show you where the Telegram is. Here we have the token and the chat user. This is my chat user ID. Okay, I'm gonna disconnect now from the service. So now I'm disconnected from the service. I'm gonna clear all my history to have like a fresh start. And let's go here, refresh. As you can see, now I'm not in the list. Okay, let's start. If I press start, okay, now I'm on the list. If I refresh, you can see that I've been added to the list. I'm gonna run the moisture sensor since it's easier to control. Okay, so here we have the moisture sensor. Now my emergency notifications are on. I'm gonna remove this, and as you can see now I've received that the soil is dry. We're activating the sprinklers. As the levels return back to normal, the sprinklers turn off and I receive a notification. Let's turn off the notifications, and now if I remove or if I put back, I won't receive anything. This is also valid for all other sensors. If I turn back on, it will get back to the regular state. Okay, so now I stop the service and I'm just now disconnected, and I won't affect anything. What's good about this approach using MQTT is that there's a broker, and these values are sent to the broker, and the broker sends to the control strategies. The control strategies then control everything, even though if the user is not on the list. So when the user is on the list, he receives only notifications, but the control strategies continue the same. If he's on the list, he would receive notifications and about everything. Okay, so let's now run the system entirely. Okay, so here we have, I'm gonna run the DHT, the SR, which is the ultrasonic, and the moisture sensor. So now we have them all run. As you can see, the values now are stable. Now it's all running. I'm gonna play a little bit with this sensor. As you can see now, my humidity is increasing. It should now increase to a limit, which is now you can see that I've received, and on the background you can see that the fan now is on, the indicator is on. Now if I remove my hand, it should get lower and lower and lower, even though it reaches the lower bound, which was 30. Now it's less than 30. It doesn't automatically quickly turn off. It turned off now when it became 18, which is in the range, the margin that we've set. Okay, now let's go to the part dealing with setup of the zones. uh, I'm gonna go here to my Raspberry. Okay, I'm gonna kill all processes. Okay, and I'm gonna go to the config file here. Okay, I'm gonna name this zone 1, for example, and I'm gonna turn it off. Now I'm gonna run my start shell, or let's run the setup Python. Okay, it's now sending a setup signal to the broker, and we're done. If I go back here to my home page, I can notice that we have a new zone which is undefined. We have to define it. So if we go into settings, we just change all the values. For example, Raspberry Pi maximum allowable temperature is, for example, 40. Minimum allowable temperature is, for sorry, it's, let's say 10. This is 40. Minimum humidity 0. Maximum, no, 50. Water level tank, let's set it to 30%. Temperature margin is 5 degrees, and humidity margin, let's say 3%. And then we update now, and we can see that's updated here. Also in our zone, in our zone list, if we go back, we can see a new zone added here, which is zone 1, with the plants, everything defined. And if we go inside here, we can see that it automatically has all things set up and good to go. It now also reads from the Raspberry, since it's we've defined it here as zone 1. So if I decide to run all my values, I can see that you can see that the values are changing